Hello and welcome back to maths. And we're going to continue our work from yesterday, looking at fractions that were greater than 1, but in this case, continuing to see whether we can convert between improper fractions and mixed numbers. Now, if some of you are paying attention, it's something we've already done, and we kind of already know the way to do it. So hopefully that'll make it nice and easy. And in our live lesson yesterday, we did kind of talk about it. So hopefully this lesson shouldn't be too difficult. But let's see and see how it goes. So first off, can you answer these questions, please, for me? Pause now and have a go. Okay, let's have a look. So what fraction of the bar is shaded blue? Well, it's split into 5 pieces, and there's 3 of them that are shaded, so 3/5. The second, what fraction of the bar is shaded green? I don't even need to count it, because I could just say 1 whole. Or I could count and say 1, 2, 3, 4, 5, 6, 7, 8, 8 pieces. 8 are coloured in of 8, so it's 8 or 1. And how many parts are yellow? 5 parts. 5 out of 8, so 5 eighths. However we want to go about doing it. That's the easiest way to think about it. So let's have a look. Here's our number line, and it goes counting in halves. So we've got the first jump, which is a half. Next jump is another half, which gets us to 2 halves, which is the same as 1. Another half gets us to 3 halves, and another half gets us to 4 halves. Now, what we can also say at this point is 2 halves is the same as 1. And 3 halves, then 4 halves is the same as 2. And there's 1 in between. Obviously, we've got enough for 1 half with 1 left over, so it'd be 1 1/2. And this is kind of a recap from before, but it's just reiterating the fact that if we have all of the pieces, we've got 1, then we have any leftovers, we'll make another fraction. And then we get to the fact that we can have 2 whole ones if we have enough there. So here is 3 halves. Okay, we know we're counting in halves because you can see each whole is split into 2. So the denominator must be 2. Then we see how many we've got. We've got 3, so that's 3 halves. And this is the improper fraction. So an improper fraction is when the numerator is greater than the denominator. And that's a recap from yesterday as well. What you could also say is that's 1 whole and 1/2, which is our mixed number. And we did look at this before and how we convert between the two of them. So this hopefully should be nice and straightforward. There shouldn't be anything new yet. So how do we represent and show mixed numbers and improper fractions? So have a look at these and see if you can think how you would show them, either as mixed numbers or improper fractions. Pause now. Okay, so what did we come up with? Well, the first one here, we've got between 1 and 0, and there's 3 jumps. So we're counting in thirds. We've gone past 1, so we can say that's definitely 1, and then 1 more third. So 1 1/3 would be my guess. There we go. Then if we're looking down here, well, we can count how many it's split into. It's split into 1, 2, 3, 4, 5, 6. So they must be sixths. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sixths. Now, interestingly here, this 1 I could move to fill in here, and that would be fill in. That would be 1 whole 1 and 4 sixths. Or I could do 10 divided by 6. I can fit 1 6 in with 4 left over, hence my 1 and 4 sixths. There we go. In this one, we've got 2 whole ones there, and this is a half, so it would be 2 1/2. Or 5 halves. So can we convert an improper fraction to a mixed number? So here we have 7 thirds, and you can see that it's thirds because each whole is split into 3. We've got 7 because we've got 1, 2, 3, 4, 5, 6, 7 in total. And then we're looking at how many holes do we have, and we have 1, 2, 1 hole here, and another whole here. So we've got 2 in total. And how many left over? Well, we've got 1/3 additional, so 1/3. We could do it that way. And I'm sure it will help me show you that in a minute. But what we could also do is 7 divided by 3. 7 divided by 3 is 2 with 1 remainder, because 2 times 3 is 6. Got 1 left over, can't make a full 3. But that 1 remainder is 1 part of the 3 we have here. So we could write it as 2 and 1/3, and that 3 of the third comes from whatever we're dividing by here. Okay, let's have a look and see if I'm right. There's the 2, and there's the third. Isn't it good? So can you convert this improper fraction? Have a look at what the improper fraction is and what's a mixed number. Pause now and have a think. Okay, so what we need to think about is how many there is in each. There's 1, 2, 3, 4, 5, 6. So they are in sixths because each of our wholes are split in 6. How many do I have? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Like that. But what I could have said is my 3 wholes. I know there's 6 in each one, and I've got 3 of them. So 3 times 6 is 18. And then I'm looking, oh, look, I've only got 5 more, so that's 5 sixths. So there's 18 sixths here and 5 sixths here. That makes 23 sixths. Or I say I've got 3 whole ones, look, and 5 sixths. It's almost easier to do this, isn't it? Let's have a look. In 6, there's 23 of them. There's 3 whole ones and 5 sixths. Hooray. Okay, so now it's your turn. Have a go at these, and then we'll talk them through. Pause now and have a go. Okay, so let's have a look what our answers are. And here they are. So first off, it says convert improper fractions to mixed numbers. So we've got 8/5. You can see 8/5 there. That's 1 whole one and 3/5. We can see it. This one, it's asking us to see how many there are. So we can just count how many are shaded, which is 12. That's 2 whole ones and 2/5. Count them again. There's 9. They're split into 4, so it's quarters. We have 2 whole ones and 1 quarter. That's our mixed number. Then we can look at this one. Each whole is split into 3, so it's thirds. I've got 5 of them. That gives me the 5. I've got 1 whole one and 2/3, which is there. The same goes for up here. What they're asking you for is to draw it out. So you go, okay, I'm drawing in thirds. So I would make my third and colour it in until I had 7. Well, that's only 3, 4, 5, 6. Oh, I need another one. 7, there you go. I've got all of them. That means I've got 2 whole ones and 1/3 left over. And you do the same for all of these. Okay, so we can convert improper fractions to mixed numbers. Now we can do that showing diagrams, but when we get to high numbers, like the one we've got here, it can take us a long time. So what other way can we have to do it? Well, in this case, what you're saying is 32 divided by 7. And that's 4, because 4 times 7 is 28. There's not enough to make a whole another 7, so we've got remainder 4. That remainder 4 is the same thing as saying 4/7, because again, we're dividing by 7 and we have 4 left. 4, the remainder goes on the top, whatever we're divided by goes on the bottom. And so our answer would be 4 and 4/7. And this is just reiterating it. 1 over 4 or 1 quarter means the same as 1 divided by 4. So 32 over 7 means 32 divided by 7. There's 32 divided by 7, which is, there's 7 across here. 32 is coloured in. We've got 1 whole one, 2 whole ones, 3 whole ones, 4 ones. That's 4 in total. And here we've got 1, 2, 3, 4. And there's 7 parts, 4/7. So it's 4 and 4/7. There we go. You see, we're good, right? Have a think. Convert these improper fractions to mixed numbers. Try now. Let's have a look at the answers. So 107 divided by 10. Well, I could fit 10 whole ones in, a remainder is 7. I can convert that 7 into the fraction. 7 goes on the top. Whatever I'm dividing by here goes on the bottom. So my answer is set 10 and 7/10. I know it's 10 because 10 times 10 is 100. I haven't got enough for any more. And this is why our times tables are so important, because it just makes our life much, much easier. The same goes over to this side. It's 22 divided by 3. Well, 7 times 3 is 21. I haven't got enough for that one, so there's at least 7, and I have 1 left over. That 1 left over is 7. The 1 goes on the top. Whatever I'm dividing goes on the bottom. So it should be 7 and 1/3. There we go. And that's the easiest way to do it. Of course, you can draw it out. That's fine. But you are going to have to, if you do this one you'd have to draw out 10 bars, and this one you'd have to draw out 7 bars. It just take you a long time. So this method of division just makes it quicker. Both ways work, and both ways will get you to the right answer. So it's really dependent upon what you feel more comfortable with. But this again is just why those times tables that you know, if you know up to the 10, whatever the number is times by 10, it just makes your life so much easier. So find the value of the star. We've got 25 of something equals 8 whole ones and some of something else. So we have to think in our 8 times table. Have a think, see what you think. So let's have a look. It's 25 divided by something equals 8 and something. Now, the thing is, we don't know what the something is, the remainder, and we don't know what we're dividing by. So how can we use this to our advantage? Well, we know it's in our 8 times table. Okay, so we can think in our 8 times table and get as close to this as possible. So 8, 16, 24. We can get to 24, so it's got to be 3. So what I'm dividing by here must be 3, because 8 times 3 is 24. And how many do I have left over? Well, the remainder, 1, because that's 24, and this is 1 more. So our answer would then be this converts to 8. The 1 goes on the top, whatever we're dividing by goes on the bottom, goes there. And there we have it. So what's the value of the star and the thing? 3 remainder 1, like we said before. So we can do it the other way around. We get to the answer. My way was easier, just so you know. And there's the diagram if we need to think through that way too. Here you go. Here's your questions for today. Have a go at these, see how you do. Pause now and give it a go. I'll hide myself. Okay, let's have a look at the answers. So the first one is converting to improper fractions. So we've got 10 over 2. So we're just dividing 10 by 2. That's 5. Then we're doing 10 divided by 3. Well, 3 times 3 is 9 with 1 left over. So that's 3 and 1/3. You should continue the same pattern going to all of those. This one says either has 7 bottles of juice. 1, 2, 3, 4, 5, 6, 7. That's all good. Each bottle contains half a litre. So each one of these, you can see here, is half a litre. How many litres of juice does either have altogether? Well, 2 halves make a whole. So we group 2 together, 2 together, 2 together. That's 1, 2, 3. And then what's left over is 1/2. So that whole answer would be 3 and 1/2. And that's the easiest way to do that one too. Dexter is converting improper fractions, and he says 32 thirds is equal to 3 and 2/3. Explain why he's incorrect. So what's your reason why he might be incorrect? Well, let's have a look. First off, you'd prove that he's wrong. So 32 divided by 3. And we think through our 3 times table, and we can get all the way up to 10 times 3, which is 30. But we can't go to 11 times 3, which is 33. So it would be 10 with 2 left over. Or that as a mixed fraction will be 10 and 2/3, because the 2 goes on the top and the 3 goes on the bottom. Explain what he's wrong. What he's actually done is taken that 33 and just put that 3 on the front there, which is a big error, isn't it? Because he's not actually done any calculation whatsoever. Finally, I'll just bring myself back now because I used that bit. We've got to find the value of the circle. So we've got 27 over something equals something and 2 left over. Now, we know the answer's down here, but how did we get there? Well, let's have a look. 27, over something equals something with 2 left over. So what we're thinking about is any times table that can get to 2 less than this, because we need 2 left over. Yeah. So 2 less than this is 25. And that's where our hint is. In what times tables is the 25? Well, 25 is in our 5 times tables. And we can fit in how many of them? 5 of them. And we're still counting in fifths because we're counting in fifths before. That would be the easiest way to do it. What you could do is say 27 divided by 27 minus the 2 left over is 25. 25, what's the square root of 25? Because both of these need to be 5. The square root of 25 is 5. So there it is as well. And it says find 2 possible values for the star and the triangle. Here's the star and here's the triangle. And what they've done is they've done the star could be 14 or it could be 7, and the star could be 2 or 4. The reason why it's 2 and 4 is because this is half of that, so this is 2 times that. That's the difference there. But having a look at it, let's think this through. 30 over something equals something with 2 left over. So what we're looking at is what times table is 28 in, and that's the giveaway. 28 is in. So if we think about our factors of 28, we've got 1 and 28. We've got 2 and 7, and we have we don't have 2 and 7, 2 and 14. Confused myself there. We don't have 3. We do have 4. It's 4 times 7. It's not in the 5 times table. It's not in the 6 times table. We're back to 7. So what we have to think about is what can we divide by here to get 2 left over, which is 28. We can't do dividing by, we can't have 2 under here because we couldn't have 2 left over. If we were dividing by 4, so we had 4 in here, for example, 4 goes into that 7 times with 2 left over, but that could be written as a half. So you could have that, or you can use one of the other ones. So we could say, okay, we can use 7 underneath. That means it would be 4 here and 7 here. Or we could have 14 underneath. That would give me 2 whole ones with 2 left over as well. So either way works. But also I think you probably could have 4 as well. Okay. Right. Thank you for going through the lesson with me. Hopefully it wasn't too difficult because we had talked about it before. We talked about it in our live. We will talk about it again in our live session just to see if we do need to. But the idea is exactly as we talked about before. You create either your diagram and think about how many full ones you have and how many you have left over, or you do your division, think about how many wholes you have and how much the remainder you have. The remainder becomes the fraction. And that's it. I hope that's okay. Goodbye, and I'll see you in the next video. Goodbye.